Today we start the gas series. Yeah, so today we start another topic, which is the gas series. And by the end of this video, you understand what pressure means, uh, how temperature relates to gas behavior, how gas volume and the pressure are related, which is Boyle's law. Also, so what is pressure? So when we are talking about pressure, this is the force exerted by gas particles per unit area on the walls of its what? Of its container. So imagine like particles are in a container. Now when we are talking about pressure, this is the force those particles are exerting to what? To their walls per unit what? Per unit area, according to the what? The area they are in. For example, water in a container. When you're talking about pressure, what force are they exerting to the what? To the walls of the container. That is pressure. And the units of pressure we have ATM, which is atmosphere, Pascal, millimeter, Hg. Yeah. Also we have two. So those are the units of what? Of pressure. Another thing also is temperature. What about temperature? What does temperature mean? So when we are talking about temperature is the measure of the average kinetic energy of gas particles. So it is just the measure of what kinetic energy are those particles having. That is what? That is temperature. And we know that when we are talking about kinetic energy, we are talking about energy of motion. Yeah. Now we are measuring that what? That energy of motion, and that is temperature. And always we use Kelvin in gas law. So when we are in gas law, we use what? Kelvin. So whenever you are given temperature, maybe in degrees Celsius, convert it to what? To Kelvin. Now, I want you to think of gas particles just like tiny balls bouncing around. The more they bounce, the higher the temperature. And the higher the temperature, the more force they exert, which is higher pressure. So, higher temperature means higher pressure. Another thing also is Boyle's law. Let's talk. So when we are talking about Boyle's law, this is just a law which states that at constant temperature, hear me clearly, in Boyle's law, we are saying at constant temperature, the volume of a gas is inversely proportional to what? To its pressure. The volume of a gas is inversely proportional to its pressure. What does this mean? If pressure increases, volume decreases. If pressure decreases, volume what? Increases. And that is where we are having the formula of Boyle's law, which is P1 V1 is equal to P2 V2. So that's the formula of Boyle's law, which is P1 V1 is equal to P2 V2. So whenever you are asked to find the pressure, you are given the two volumes. You should be given another pressure also. Yeah. A gas occupies 2 liters at 1 atm. If the pressure increases to 4 atm at constant temperature, what is the new volume? Now, when you are solving such questions, the first thing that you should do is collect the data. What's our data? So for our data, pressure 1 is equal to 1 atm, because they are saying a gas occupies 2 liters at 1 atm, which is 1 atm is our pressure 1. Volume 1 is what? 2 liters. Now the statement continues by, if the pressure increases, which means now we are coming to what? To the final pressure. The 1 atm or the initial pressure. Now we are going to, which means 4 atm is the final pressure. If the pressure increases to 4 atm at constant temperature, what is the new volume? So which means we have been given the initial pressure, we have been given the initial volume. What we are looking for is what? The final volume given the what? The final pressure. So our P2 here is equal to 4 atm. Now when we are talking about finding the value of V2, we just need to place everything in this formula. And we start first by, since we are looking for V2, we make V2 the subject of the formula. So that's the formula for what? V2, which is volume 2. What is our P1? Our P1 is 1 atm. So this is equal to 1 atm times, what is our volume 1? our volume 1 is what? Is 2 liters. Over, what about our pressure 2? Our pressure 2 is 4 atm. Now we know that 1 atm times 2.0 liters is just 2.0. So this is 2.0 atm liter over 4 atm. Now atm and atm will cancel, which means we are just going to remain with what? Liters. What is 2 over 4? 2 over 4 is what? 0.50. 0.50. So that's our final volume. That's our volume 2. And I want us to understand Boyle's law by using this example. We said that if pressure increases, volume what? Decreases. Now let's look at the truthfulness of this. Let's look if this statement is true or correct, because we started with the volume of 2 liters and the pressure of 1 atm, and the pressure increased, which means our volume should decrease. Now the question that comes to us, did the volume decrease? The answer is yes, which means we have proved what? Boyle's law. So that's how you are going to find your volume 2. Now you are going to find that you can be given the final volume, the final pressure, but you need to find the initial volume or the initial pressure. All you just have to do is place the data just like we did. Yeah. So let's go ahead and do the second example. So here is the second example. So in the second example, we have been given like a gas 500 sample. 5.0 liter sample is compressed to 3.0 liter, which means this 5.0 liter has been compressed to 3.0 liter, which means 5 liter is the initial and 3 liters is the what? Is the final at constant temperature. What is the final pressure if initial pressure is 2 atm? So let's go ahead and write the data. So there we go. We have the pressure 1, we want the P2. So we have just made P2 the subject of the formula. Then there's nothing difficult. We just have to place the values and find what? The final answer, which is the pressure 2. Yeah, so the answer is 3.33 atm. And what has happened? The initial volume was 5 and it decreased to what? To 3. So what happened to pressure? Because volume decreased, pressure increased from 2 atm to 3.33 atm. Now let's talk about the the unit conversion for pressure units. So you're going to find that in gas laws, you can be given atm or in terms of kilopascals or millimeter Hg. Yeah, so here is just the conversion that is going to be helping you. So 1 atm is equal to 101.3 kilopascals, which is equal to 760 millimeter Hg, which is equal to 762. So 1 atm is equal to 760 what? 762. And also 1 atm is equal to 760 millimeter Hg. Yeah. So let's try again. Let's do an example, a simple example in units conversion. So we have been given convert 380 millimeter Hg to what? To atm. So how do we convert this 380 millimeter to what? To atm. So we know that 1 atm. So the best way you can do this is not secondary now. So we do the wrong way. So we just do 380. Now this method of units conversion is very, very important, and it will help you to be solving things faster. So you know that 1 atm is equal to 760. So what do? You just multiply. Now which one are you going to put on top? Is it 1 atm or 760? Now you want to cancel the millimeter Hg. So for you to cancel 1 millimeter Hg, you have to put atm on top. So you put times 1 atm, which is equal to what? 760 millimeter Hg. So you just cancel that and that. Then you just do this one over this one. You are going to find the answer to be what? 0.50 atm. So In terms of units conversion, always use this. Instead of going 1 atm is equal to what about what, no, just multiply. Your aim is to cancel, to only remain with what, the one you want to convert to. Yeah, so which is what, atm. So that's just how we convert. So whenever you have been given atm to convert to 760mm hg, that's what you do. How about to the same story? What about kilopascals? You use 101.3 kilopascals. Thank you for watching, and don't forget to subscribe and watch the next video, which is on Charles law and Avogadro's law.